Today, I'm gonna start with a new topic, which is analysis of trusses. Just a reminder, at the beginning of this semester, I told you we have three types of structures. We have beams, we have frames, and we have something called trusses. Beams, if you have a beam, looks like this in the isometric shape, and we are considering this beam as supported here on hinge or roller or fixed. Frames, we are considering this beam by this column, both of them at the same time. So the beam looks like this, just horizontal line, and we have supports. But for frames, we have horizontal beam and vertical member, which is column, and then we have supports. So we have column and the beam at the same time. This structure can be called frame. Horizontal member, which is called beam, so this structure is beam. For trusses, we have a very interesting structure. We have member, we have another member, another member, another member, another member. All of these members connected together at these hinges or at these joints. And this structure is supported by supports, hinge, or roller. This structure can be called truss. So guys, trusses looks like this. We have many members, this member, and this member, and this member. All of these members are connected together at something called joint. If you construct a structure like this, and finally this structure is supported here, and supported here, and supported there, this structure can be called truss. This structure can be made from steel most of the time, can be made from wood sometimes. So most of the time, this structure is made from steel. This one is a huge truss for bridge. This one is a very simple truss for building. But the idea for truss is a structure composed of members joined together at their end points. We have member, we have another member, another member, another member, another member, another member. We have many members connected together at their ends. These members supported by supports, hinge or roller. This structure can be called truss. If you would like to watch a video showing up the meaning of truss, we can watch this video. We have a canal and we would like to construct a bridge between the two sides of this channel. So this truss or this structure is made from steel. So everything or every element is made from steel. we have steel members connected together at this location and this location and this location. This location can be called joint. So members connected together. Guys, keep in your mind when you are watching this video that these members connected together to form triangles. Did you see any rectangle or square or something like this? All of these members are connected together to form triangles. Just to keep it in your mind, okay? Okay, so the bridge is constructed. What you have on the other side, we have here supports. This support can be hinge or can be roller. And this support is rested on this foundation. Can you watch? We have here a hydraulic jack helping us to lift this bridge until you reach to the level of foundation. This is the support. So finally, you have this bridge. So what do you think? Is it interesting? Trusses is a very interesting structure. So to summarize what we watched, trusses is members connected together, most of the time steel members, connected together by joints and supported by supports to form this structure. The member can be connected. This is a member, this is a member, this is a member, and we have another member, all of them connected together by this joint. We have different techniques to support or to join these members together by rivet, by bolts, by welding. It's not our issue in this course. So the actual connection between members, something looks like this. It's called gusset plate. We are in this course converted this actual shape of the truss to this shape. So the member, which is this shape in the real life, can be considered as this line. That makes sense? The second member, the third member, the fourth member, all of them connected together at this joint, which called joint B. So the truss in the real life looks like this, but in our course will be like this. So each member joined together by a smooth pin. All loading are applied only at these joints. We cannot expect any load on the member directly. Doesn't make any sense. To have a truss, that means we have three conditions. All members are joined together by smooth pins. We are assuming this joint as smooth pins. All loading are applied at the joint. No way to find a load on the member itself. It must be at a joint. We have only axial force. We don't have shear force diagram. We don't have bending moment diagram. We don't have the only internal forces in trusses, only axial force. We don't have shear force diagram or bending moment. We don't have shear forces or bending moment in trusses. We have only axial forces in each member. So for any truss, if you have these three conditions, that means your structure can be called truss. All members joined together by a smooth hinge or a smooth pin. All loading are applied at the joints. We don't have any load on the member like this or like this. Doesn't make any sense for trusses. And the only internal forces we have is axial force. Guys, any questions so far? Any questions so far? This one is very important. I would like to repeat it because it's very important to understand what is the meaning of trusses. If you have any question, let me know. Trusses are structure, consists of member, 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 many members. These members connected together at these joints. These joints is pin, smooth pin. These members connected together and supported by supports, hinge or roller. We don't have fixed for trusses. Anyway, the only applied load must be at joint only, vertical or horizontal. We cannot expect any load on the member itself. Doesn't make any sense for trusses. The only internal force, if you remember, we have three internal forces in beams and the frames. One called axial force. If you remember that, axial force. We have shear force. We have bending moment. That's right. This is for beams or frames. But for truss, we don't have shear. We don't have moment. We have only axial force. So this member will have axial force, tension or compression. That's it. That's it. This is the defining of trusses. Truss looks like any other structure. Can be stable or unstable. If your structure is stable, can be determinate or indeterminate. How can I figure out the indeterminacy of a structure? Is it stable or unstable? We need to figure out the relationship between number of equations and the number of unknowns. If the number of equations equal number of unknowns, your structure is stable and determinate. Guys, some of you during the homework said the structure is determinate. That's wrong. You have to tell me your structure is stable and determinate. Don't say determinate and that's it. That's wrong. You have to say stable and determinate. If the number of unknowns greater than number of equations, your structure will be stable and indeterminate. If the number of equations greater than the number of unknowns, your structure is unstable. That makes sense? So we have three cases: stable and indeterminate, stable and indeterminate, and unstable. How can I figure out the number of equations and the number of unknowns? We have a different technique for trusses. We have a different technique for trusses. Number of unknowns equal B plus R. B is the number of members. As I told you, any trusses consist of members connected together. Can you count how many members do you have? So B is the number of members. R is the number of reactions. Add them together, you can figure out the number of unknowns. Number of equations equal to J. J is the number of joints. As I told you before, these members are connected together at this joint. Can you count how many joints do you have? How many joints is J? So the number of equations will be 2J. We have special cases regardless how many unknowns, how many equations, I'm gonna say this structure is unstable. If so, the truss is unstable regardless how many equations, regardless how many unknowns. I don't care. If I found one of these situations, I have to say this truss is unstable. If all reactions are concurrent. Can you see here? We have hinge, so we have two reactions. We have roller, so we have one reaction perpendicular to this base of the roller. Nothing else. This reaction and these two reactions are concurrent, intersect at one point. All of them intersect at one point. This structure or this truss is unstable. If all of reactions are parallel, we have roller, we have roller, we have roller, we have one reaction, we have one reaction, we have one reaction. All of these reactions are parallel. This structure or this truss is unstable, regardless how many equations, how many unknowns. If you have one panel is square or rectangle without at least one diagonal, without at least one diagonal. One diagonal is important. Do you remember when you are watching the video, I told you these members connected together to form triangles. You must have triangles. Can you see? We have here square or rectangle without one diagonal at least. That means this structure is unstable. For trusses, we have three situations. Please be careful. If you have all of your reactions are concurrent, your structure is unstable. If all of reactions are parallel, the truss is unstable. If you have one panel without at least one diagonal, this truss is unstable. I would like to show you why this truss will be unstable. You can watch this video.
Although this truss satisfies Maxwell's stability requirements, it is not stable because it is not fully triangulated.
Can you
Although
see?
this truss satisfies Maxwell's stability requirements.
Can you see the panel without at least one diagonal? We have a huge deformation for this panel. Can you watch why this panel is unstable?
It is not stable because it is not.
So this truss is very good. The only part which is unstable is this part. If you have only at least one part unstable, the whole structure will be unstable. That makes sense?
Not fully triangulated.
We must have at least one diagonal. At least. Probably we have two. That's fine. It's more stability. But at least you must have at least one diagonal. If you don't, this part will be unstable. The whole truss will be unstable. Any questions so far? Guys, do you have any questions so far? If you have any question, let me know. Okay. Let's do some examples on stability. One of the questions in the coming exam, check stability for beams, frames, and trusses. Let's do on trusses. Let's start with This one. What do you have? This one is a roller. This one is a roller. So we have one reaction here and one reaction here. Do you have any other reactions? No. Please, can you check? Do you think these reactions, all of them are concurrent? No. All of them are parallel? Yes. This truss is unstable. I don't need to count how many unknowns, how many equations, because I found a special case. All, you don't need to say this, all of reactions are parallel. You don't need to do this. Just to say this truss is unstable. That makes sense? Let's do this one. We have here two reactions. It's hinge. We have here one reaction. It's roller. Do you think all of these reactions, all of them are concurrent? No. All of them are parallel? No. Do you think we have one panel without at least one diagonal? No. Okay, you are good. Keep going. How many reaction? How many members? How many joint? R, B, J. How many reactions? 3. How many members? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. So we have 11 members. How many joints do you have? 1, 2, 3, 4, 5, 6. We have 6 joints. So, number of unknowns, which is B plus R, equal 14. Number of equations, which is 2J, equal 12. That means number of unknowns is greater than number of equations. If you go back, this truss will be stable and indeterminate. How many times this structure is indeterminate? The number of the number of unknowns greater than the number of equation by 2, so 2 times. Statically indeterminate. Easy? Very easy. Very easy. Let's do one more. Let's do one more. You can teach your kids how to figure out this truss is stable or unstable. Like this. We have a truss. We have 2 reactions. This one is hinge. This one is roller. Do you think? Please ask yourself these 3 questions. Do you think all of these reactions are concurrent? No. Do you think all of these reactions are parallel? No. Do you think we have one panel without at least one diagonal? No. All of these are triangles. We don't have a square or rectangle. You are good. Go ahead and count how many reaction, how many member, how many joints. Let's do how many reactions. 3. How many members? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm trying to put marks to avoid missing anyone. How many joints? 1, 2, 3, 4, 5, 6, 7, 8, 9. Go ahead. B plus R equal 18. 2J equal 18. Number of unknowns equal number of equations. This structure will be stable and determined. That makes sense? Guys, if you have any question, let me know. If you have any question, let me know. For this truss, this one, first step, please put your reactions. This one is hinge, we have 2. This one is hinge, we have 2. Ask yourself 3 questions. Do you think all of these reactions are concurrent? No. All of them are parallel? No. Do you have panel with at least one diagonal? That means, do you have a square or rectangle? No. Okay, go ahead and count how many reactions, how many members, how many joints. Reactions, we have 4. Members, 1, 2, 3, 4, 5, 6, 7. How many joints? 1, 2, 3, 4, 5. So B plus R equal 11. 2J equal 10. Number of unknowns greater than number of equations. So this structure will be stable, but indeterminate. How many times this structure is indeterminate? This unknowns greater than this equation by 1, so 1 time. So thank you for every student who is solving the homework like this, because there are few students are cheating the solution from the solution manual. So they don't write anything. They had at least don't draw the structure, don't draw the problem. They didn't draw the problem because they don't have time. They are cheating from the solution manual. But if you are solving on your own, you have to draw your structure. You have to count number of reaction, number of members, number of joint. You have to say what is the relationship between B plus R and the 2J, and you have to tell me what is your final conclusion. This is the best way to solve this type of structure. Let's do, before leaving this part, anybody has any question? For stability, keep in your mind, for stability, your structure can be stable or unstable. If your structure is stable, can be determinate or indeterminate. Number of unknowns for trusses is very simple, just B plus R. B, number of members. R, number of reactions. Number of equations equal to J. J is the number of joints. Guys, we have 2 cases. Keep it in your mind. Don't worry. If you have this cross, if you have cross like this, we have 2 options. Both of them are correct. One of you will say, hey, I will count this member as 1 and this member as 1. So this cross will be counted as 2 members. So I will not count this as a joint. This intersection will not be counted as a joint. We have another solution. Both of them are correct, believe me. Well, one will say, hey, I will count this member as a member, this one as another member, another member, another member. So how many members for this cross? We have 4 members. That's correct. But in this situation, I'm gonna consider this intersection as joint. Both of them finally will give you the same answer, believe me. So don't be worried. You have 2 situations. Both of them work for any intersection. If you count, you have intersection and count this is a member, this is a member, this is a member, this is a member. So this intersection will be counted as a joint. If you don't consider this intersection, so you consider this is a whole member, this is a whole member. So I will not consider this intersection as a joint. Will not. Any question, guys? If you have any question, please write your question or talk to me. Okay, just a reminder. I told you that for truss, we have only one internal forces, which called axial force. We don't have shear, we don't have moment. So we are looking for what is the value of the internal force, what is the value of the axial force in this member, or this member, or this member. And is it tension or compression? Okay? Sometimes we have members, the internal force or the axial force in these members are 0. These members can be called 0 force members. We have 2 cases. If you found one of them, this member will be 0 force member. Let's try with the first case. The first case, you have to get 3 conditions. Joint with 3 members. Guys, I have a question. This joint, which called joint F, how many members intersect at this joint? Can you count? This member, this member, this member, this member, this member. So how many? 5 members intersect at joint F. No, we are looking for joint has 3 members only. So joint F will not be considered. Joint G will not be considered. Joint D will not be considered. Why? Because joint G has 2 members. No, we are looking for joint with 3 members. I believe joint B will not be considered. We have 4. Joint C will not be considered. We have 4. I believe probably joint A, joint H, joint E can be considered. So we are looking for joint has 3 members only. two of the three members, two of them are collinear. What is the meaning of collinear? Collinear means on the same line. This member and this member are collinear. This member and this member are collinear. This member and this member are collinear. Let's see joint A. We have three members. 1, 2, 3. Do you think two of them are collinear? Do you think two of these three members are on the same line? No. Please forget joint A. Let's do it with joint E. We have three members. 1, 2, 3. Do you think two of them are collinear? Yes, I think. This one and this one are collinear. We're still good here. For joint H, we have three members. 1, 2, 3. Do you think two of them are collinear? Yes, I think. This one and this one. So we're still good with joint H. So after the first condition and second condition, we have only two joints can be considered. Joint H and joint E. The third condition, no external force at this joint. Do you think joint H has external load? No, we still good. Do you think joint E has external load? Yes, we cannot be considered anymore. So the final conclusion for this truss, joint H is good, is fit for this case. So what is the final conclusion? The third member is a zero force member. This one will be 0. Do you remember? We have 3. This one and this one are collinear. The third one will be 0. So the final conclusion, member HB is 0 force member. The internal force in this member is 0 without calculations, without any reactions, without any calculations. Any question, guys? We have 3 conditions. We have 3 conditions. Number 1, joint with 3 members only. Number 2, 2 members are collinear. Number 3, no external load at this joint. The final conclusion, the third member will be 0. Any question? The second case, it's very simple, a little simple. We have only 2 conditions. And then we can get the final conclusion. The first condition, joint has 2 members only. For this truss, do you have joint with 2 members only? Joint number B, joint B has 4 members, will not be counted. Joint E has 3 members, will not be counted. Joint D has 3 members, will not be counted. Joint C has 2 members, yes, can be counted. Joint A, 2 members only, can be counted. This is the first condition. The second condition, no external forces at that joint. Do you think we have external load at joint A? No. Do you think at joint C we have external load? No. So the 2 joints will be good. Joint A and joint C are good for this case. What is the final conclusion? The 2 members are 0. Believe me. At joint A, this member and this member are 0. At joint C, this member and this member are 0. The 2 members at this joint are 0 force member. Let's do an example. We have example here, and we can expect question like this in the coming exam. I'm giving you a truss, and I will ask you to identify all 0 force member without calculations, without reactions, without anything. Just tell me which members are 0 force member. Please follow my rule. If you have this truss, I'm gonna redraw it one more time with a pencil. Pencil, not a pen. We have hinge, we have roller, A, E, we have external load, we have external load F1, F2. Please don't forget, this roller will give you a reaction. How much? I don't care, but it's a reaction. This one will give you 2 reactions. How much? I don't care, but we still have reaction. We have here joint B, joint C, joint D, joint J, joint G, F, H, I. Guys, to solve this kind of problem, I'm gonna start with case number 2. Then I will go through case number 1. Case number 2, saying you have joint with 2 members only, no external load at this joint, the 2 members are 0. Can you tell me which joint is fit for case number 2? Joint has two members only. No external load at this joint. Any answer? Please go ahead and write your answer. Do you think we have joints with 2 members only and no external load at this joint? Any answer? I'm looking for a joint, guys. Remember, I'm looking for a joint has 2 members only and no external load at this joint. Thank you, Marcus. Thank you. Joint B. How many members do you have at joint B? 2? Yes, we have only 2. So 2 members only. Do you have any external load? Do you have any applied load at this joint? Is it given in the problem Any external load? No. So, no external load. The final conclusion, this member and this member, which are connected at this joint, are zero force member. The two members are zero. So the final conclusion, this member is zero, this member is zero. Just draw a circle. Circle means zero. And delete it. Delete it. Please, if you have a member which is zero, delete it. This is the reason why I told you I need to redraw. Redraw with a pencil. Because if you have zero force member, I'm gonna delete it. Also, joint D. How many members at joint D? Two members. Do you have any external load? No. This member and this member are zero. I can delete them from the truss. Please, one more time. For case number 2, ask yourself, you have any joint has two members only and no external load at this joint? One will say, hey, joint E, right now, after deleting this member, joint E has two members only. Where? This one and this one. You are right. Do you have any external load? Yes, we have. Where? We have reaction. Reaction is external load. So will not be counted. Joint A has two members. That's right, but we have two reactions. So I am done with case number 2. There is no more joints fit for case number 2. Let's try case number 1. So the second step, case number 1. Just to remind you, case number 1 is looking for joint has 3 members only. Okay? Do you have joint with the 3 members only? 3 members. This one, no. This one, yes. This one, no. This one, yes. This one, no. This one, yes. This one, no. This one, no. We have only 2. So we need to check 3 joints, C, F, H. Probably one of them will work. Okay, so the first condition, joint has 3 members only. Please, 2 of them are collinear. Collinear means on the same line, like this, or like this, or like this. Let's start one more time. For joint H, do you think 2 of them are collinear? Yes, I think. This one and this one. So we still good with H. For joint F, do you think 2 of them are collinear? Yes, we still good. For joint C, do you think 2 of them are collinear? Do you have any 2 members are collinear at joint C? No. Please forget joint C. So the final competition will be between H and F. Let's see. What is the third condition? No external forces. at that joint. Do you think joint H has external load? No. The third member will be 0. So this member will be 0. This member can be deleted. Please go ahead and check the other joint. Do you think joint F has external load? Yes, I think we have external load F2. So please forget joint F. Any question? Guys, after you are done and you deleted member HI because it's 0, please recheck one more time for case number 1. I'm sorry, recheck. Why? Probably something will change. Nothing change at A, it's still not fit. C not fit. J not fit. E not fit. F not fit. G not fit. What about I? Joint I. Do you think we have 3 members right now? I think yes. 1, 2, 3. One of you will say, hey, joint I has 4. 1, 2, 3, 4. Guys, I deleted the vertical member. I deleted it. Why? Because it's 0. If the member is 0, please, you can delete it. Once you delete the vertical member, joint I has 3 members. 2 of them are collinear. No external load at this joint. The third member will be 0. So this member will be 0 also. If this member is 0, I can delete it. Once you deleted the member, please go ahead and recheck one more time for case number 2. Do you have joint with 2 members on, I'm sorry, with 3 members? 2 of them are collinear, no external load. You will not find any more. So the final conclusion, member AB, member BC, member CD, member DE, member HI, member GI are 0 force members. One more example. One more example. For this truss, we need to identify all. Guys, I'm telling you all. That means if you missed one, you will deduct. I will deduct few points. You have to tell me all 0 force member. Just for your information, we have here 1 reaction and we have here 2 reactions. Please put them at the beginning. The second step, I'm gonna redraw this truss with a pencil. We have here vertical load 2, vertical load 2, vertical reaction, horizontal reaction, and vertical reaction. Joint A, B, C, D, E, F, G H I J K L M N O. Guys, I'm gonna start with case number 2. Please start to check case number 2. You have joined with 2 members only and no external load. Just 2 conditions for case number 2. Joint has 2 members only, no external load. Please go ahead and check and tell me, anybody can tell me, do you have joint with 2 members only and no external load? Please check. This truss, do you have joint has 2 members only and no external load? Any answer? Guys, any answer?
No, we don't.
What about joint F? How many members do you have? We have 2, but we have reaction. Joint E, we have 2, but we have reaction. So no joint fit for case number 2. Okay, let's try case number 1. Please review with me. Case number 1, joint has 3 members. 2 of them are collinear, no external force. Okay, what about joint M? This member, 1, 2, 3. 2 of them are collinear, no external load. The third member will be 0. So this little member is 0. If this member is 0, I can delete it. If you delete it, what about joint B? 3 members? Yes. 2 of them are collinear? Yes. No external load? Yes. The third member will be 0. So this vertical member is 0. If this member is 0, delete it. Oops. What about joint K? How many members do you have? 3. 1, 2, 3. 2 of them are collinear, no external load. The third member will be 0. So this one will be 0. If this member is 0, delete it. If you delete it, what about joint N? 3 members. 2 of them are collinear, no external load. The third member will be 0. So this one will be 0. If this member is 0, delete it. If you delete it, what about joint L? 1, 2, 3. 3 members. 2 of them are collinear, no external load. The third member will be 0. If this member is 0, I can delete it. What about joint C? We have 3 members, 1, 2, 3. We have 3 members. 2 of them are collinear, but we have external load to keep. So no way. If you repeat these steps on the other side, you can find this member is 0, this one is 0, this one is 0, this one is 0, this one is 0, can be deleted. And you can say this one is 0, 0, 0, 0, 0. So the final conclusion of this truss, all of these members with red color and green color are 0 false member. That's enough for today. I'm gonna continue next meeting and finish up this truss next week. Before leaving, do you have any question?